You guys ready? Hello?
Hello.
All right, good. Calculus. Some people are here, some people are not. And for that one person that's not here, we will ridicule them later. Okay, 1.2, limits of functions using properties of limits. Okay, find the limit of a sum, difference, product, power, all this other good stuff. Okay, basically all types of math that we can try and do. Okay, so we're trying to find the limit of those. Okay, so what we said the other day, okay, if f of x, okay, is some constant, or a is a constant, which is any real number, the limit for that would be that real number. There's no variable. Okay, constant is no variable, just the number. Okay, so it is the limit of f of x. If f of x is a, the limit is a. Limit of identity function, so if fx is equal to x, then for any number c, okay, what that means, very plain English, plug in the c value to your function. Now, when can I not plug in the c value to my function? We talked about it the other day. We had an old not bald guy, but balding guy, white hair, came in here, said when we should. Okay, whole. Okay, what else? Domain restrictions, yes. Domain restrictions in which that I cannot plug that in. Okay, so there's asymptotes, wholes, undefined, all that other good stuff. Okay, so this one just plug in as is, makes it quicker. Okay, limit of a sum. Okay, the limit of f of x and the limit of g of x both exist, then it's basically those two together, and then as x approaches c, plug that in. So you should just get those two individually. So it means I could break up two limits together, you know, that are already together, two different functions. I could break them up into two separate limits, because sometimes I will have one that is going to be a number and the other going to be like undefined or something like that. So if I'm doing this, I could actually have for one then the other. So let's say, for instance, G would have a domain restriction, but F does not. Okay, and my G would be some type of thing where I have to have a whole where I could solve for it, see what the limit of that function is going to be. So the limit, so at that point it is undefined, but there's going to be a limit right there. So it would give me an answer, but not initially when I just plug in the number. So I could separate this, take f of x, just plug it in, I'm good. But this one I would actually have to do the limit process to see if the left hand and right hand both go to the same number. Limit of the sum of the two functions equals the sum of their limits. A lot of things are just basic stuff, okay, but it's very wordy. It is. It is very wordy. Same thing goes for the subtraction. Same thing goes for multiplication. Okay, same thing goes for multiplication. All right, for this one right here, what would I do with this one? Plug it in, right? Is there a restriction? No. I can just plug it in, right? So that means it's going to be 3 squared, which is 9. There we go. For B, is there a restriction? Nope. So what do I do? Plug it in. My answer is? I think I heard it. There we go. For this one, is there a restriction? No? No? Okay. So if there's no restriction, then I just need to plug it in. So what is my number going to be? 10, right? 1 plus 4 is 5, times 2 is 10. All right, what about this one? Is there a domain restriction? I heard yes, I hear no. The domain restriction refers to the function. Is there a part of this function right here, the 4 times the quantity of 2 minus x, is there a domain restriction on that? Say no.
No.
No, there is no domain restriction, so it doesn't matter if it's going to take the limit as x approaches 2 from the right-hand side. That's going to be the exact same as what it would be on the left-hand side, right? Because there is no restrictions. So it's just going to be 2, right? So it's still just going to approach 2. The only time I have to really deal with this is if there is a restriction at 2. That would give me an issue. If there's some restriction at 2, I would say, oh no. Okay, good. All right, so this is going to be 2 minus 2 is times 8. Find a limit for a piecewise defined function. We did piecewise in the calculator the other day. Hopefully you guys wrote down the steps. If not, you could go back to the video, write it back down, and then go from there. All right, so this is like a warm-up too. So find the limit as x approaches 2 if it exists. First, left hand and right hand. Is there restriction? Is there going to be a restriction for the left side of 2? Is there going to be a restriction on the right side of 2? Say no. No, they're both going to be just whatever it is at 2, right? So let's see. What does the left side go to? Come on now. What is 3 times 2? Plus 1? So my top goes to 7, doesn't it? So that would be the left hand of this function, right? Say yes.
Yes.
That's the left hand of this function. Now, to the right side. So I'm going to plug in the 2. So it's going to be 2 minus 1 is
1.
times 4. Now, for this limit to exist, they both have to go to the same number, right? Do they? No, they do not. So limit does not exist. So if this was a left side or a right side type of answer, I could actually do that, right? If it was a left side, I would say 7. If it was a right side, I'd say 4. Find the limit of a power and the limit of a root. Okay, so it's basically at C, plug it in here, and whatever my power is. So it's basically, I can plug it in here, then take it to the power. That's what that means. So if you notice, I move the power to the outside of the function there. So I would do this anyway. So I'd actually do this, the limit of this, take it to that power. And the same thing for roots. Okay, exists. And if n is greater than or equal to 2, is an integer. Why 2? Is it a root if it's just a 1? We don't have the 1th root, do we? No, we don't have the 1th root. We have square root, cube root, 4th root. We don't have a 1th root. So that's what that means. Okay, so it's basically the same thing like I said. Take x approaching to C. Right here, put that in. Okay, whatever my answer is, then take that to the root. So it's kind of like just order of operation. You would do this part first. All right here. Is there restriction on this? No restriction. So what is my answer? Do I need to like set up like a coffee bar? Like everyone comes in here and get a little espresso shot first thing in the morning? 32, right? So I need like to start passing out energy drinks. It doesn't matter if you crash in the afternoon, just as long as you're good for this class, right? Okay. All right. Okay. Any restrictions on B? No. So let's go ahead and plug it in, and my answer is -1. Okay. So n is a positive integer. So what would I do? Okay, so my answer is going to be c to the n. That's it. Why did it identify that it had to be a positive integer? What would happen if it was not positive? What happens to negative? You move it to the denominator, don't you? Say yes.
Yes.
Yeah, you would move that to the denominator. You would move that to the denominator. If it was negative, it would be 1 over c to the n. And then that would give me a little bit of different type of answers. Now, positive integers. Okay, so integers are your like whole numbers, your positive and negative numbers. So integers are positive, negative, but this says only positive. What if it said to the 1/2 power? This is algebra right here. This is, if it said to the 1/2 power. It would be root. Whenever I have power as a fraction like this, the top is my power, my bottom is my root. Okay, so that would be basically saying square root of c. Like I said, I'm not expecting you guys to remember everything right away, but that's why I try to ask these questions and go over it. This one right here, is there a limit, a restrictions? Any restriction? No. Why is there no restrictions at all?
Because it's to the third.
It's third root, right? It's third root. Can I have negatives inside a third root? Yes. Square root, I cannot. All even number roots, I cannot have negatives. That would give me odds. That would give me imaginary numbers. But with a third, I can. Any odd number root, I can do that. So there is no restriction, so it's going to be 16 plus 11 is going to be 27. Cube root of 27 is?
3.
There we go. All right, this takes me back up to what I was talking about. Okay, with my fractional exponent, the top number is my power, the bottom number is my root. Top number is my power, bottom one's my root. And the same thing. Do this first and then take your power. Is there restriction here? Nope. Okay, now I'm going to rewrite this before I do it though. So I'm going to go ahead and plug it in. So it's going to be a plus 1 is 9, right? So it's basically asking for the square root of 9 to the third power. So with my fractional exponents, that's all I'm doing. I'm plugging in my limit, I'm doing that, and then worry about my exponents. So trust me, I always like doing my root first because it makes my numbers smaller. So if I take 9 to the third, that's going to be like, was it 271? Something like that. I don't know. I can't remember. You know, I suck at math. Anyway, so square root of 9 is 3. Now 3 to the third power is?
27.
There we go. Okay, so find the limit of a polynomial function. P is a polynomial function, then it's basically going to be of this, plug it in there. And whatever that's going to spit out. Sometimes you're not going to get a number out of it, you're going to get another expression. You might get like a 2x minus 1 or something. That's what that means. All right, there's that polynomial function. Is there restriction on my domain? Say no. No. There is no restriction. Okay, so we get to plug in. So that's going to be 3 squared is 9 times 4 is 36 minus 3 plus 2. So my answer is 35. Okay, let's take a look at the next one. Is there restriction? No restrictions, right? No problems there, so we can plug in. So that's going to give me a -7, and that's going to give me a -4, and that's going to give me a -2. Feel free to check my math because I'm not very good at it. Okay, so that means I get -11, -13. Please, please, please make sure you are checking my numbers all the time. Okay, I do go through this and I do make mistakes. I do. Every once in a while, I'll actually do it on purpose. Just to see if you guys are awake and following along. And if you catch me in a mistake, I'll give you guys a nice prize. You get a cool sticker. So, speaking of that, where's your water bottles? I see 1, I see 2. That's it? Only 2? Is that reusable? 3. There we go. All right. That's it. Find the limit of a quotient. Quotient is a division, right? Quotient is a division. So if the limit, okay, exists, so both for them to exist, right here, top exists, bottom exists, and the limit of C does not go to 0 because that would be undefined. Very good. That's all you gotta do. Limit of top over limit of bottom. Average rate of change. Is this a slope formula?
Yes.
Yeah, that is slope formula, isn't it? Yeah, that's just basic slope formula. So delta y over delta x, where delta implies the difference, the change. Okay, mathematically, delta means change in between those values. All right. Find the limit of an average rate of change, okay, of this from 2 to x, and x cannot equal 2. Just plug it in, right? Yes? So it's going to be from 2 to x, yes? So it's going to be f of x minus f of 2 over x minus 2. Did that make sense? Did I confuse anyone? Please speak up. Yes, go ahead.
X is our B.
Huh?
X is our B. And
Yeah,
A.
x is the b. So this is, in that case, this is my a and this is my b. Or x1 and x2, however you want to. Does that make sense? Or no? Hopefully?
We just won't get a number.
Huh?
We just won't get a number.
Are you sure?
Yes.
Are you sure? Are you positive? Okay, so let's try the f of x. f of x, I would just write x squared plus 3x, right? Say yes. Okay, now minus f of 2. So let's plug in f of 2. So that's 4 plus, which is? Yeah, so it's 4 plus 6, because I'm plugging this in. Ah! No! Don't break, this is my last one. All right, so I'm going to get 10, right? So it's going to be minus that function, which is? No! Okay, hopefully this one keeps working. That's the reason why I traded out. This one stopped working a while ago. All right, so what do we have? What did I say, minus 10? There we go. Minus 10 all over x minus 2. Now, this should be like some big blaring sign that says F that. In your head, you should look at that and say F that right there. What does the F stand for?
Factor.
Factor. Okay? Whenever you see a trinomial set up like this, and you have a quotient, you have a fraction problem like this, you should always look to try and factor it, because guess what? It goes away quite often. Now, I'm going to give you guys a moment. Factor the top. Factor the top and write on your paper. Because I know you guys are all super geniuses and can do it in your head. All right, so it's going to factor out to be x plus 5 and all over. There we go. Okay, I found it. I did everything I needed to do. I'm able to cancel that now, right? Okay. In this case right here, why did it say x cannot equal 2? Because what would be in the denominator?
0.
Very good. I would have 0. And so therefore it would be undefined. But by doing this right here, I found that I had a hole. Okay. This is called a removable discontinuity. A removable discontinuity is I could factor it out. Okay, and so I will have a hole in my line that I factored out and I could see x still cannot equal 2, but I factored it out to be able to do this. So I removed the discontinuity in my function. Now, find the limit as x approaches 2 of the average rate of change from here to here. So, hey, look, we just did that right there, right? So find the average rate of change. We got that right here. Okay, we set it up. And now I can find this, find the limit as x approaches 2. So the limit would be, written like this, as x approaches 2 of my function, which is x plus 5, because I was able to remove this piece right here. So I'm going to be left with 7. Make sense? Super easy, right? All right, so I think that one's for, yeah, that one's for tomorrow. So don't forget, like, share, and subscribe. Hit that notification button. We're going to use the rest of class to be able to work on, we got 10 minutes.